Hello and welcome back, Precalculites. We are in day 3 of 0201Notes. You should have this 2-3 note sheet. If you don't have it, you can print it off of Moodle. We're going to be talking about the applications of quadratic modeling today, and two of the big applications are maximum problems and also height of an object. So the first one has to do with finding the maximum area. And when we set this up, we read the problem, and it says we're looking for rectangles with perimeters 80 feet and dimensions of one with the maximum area. So you see two key words in this. So among the rectangles with perimeters of 80 feet, find the dimensions of the one with the maximum area. You see perimeter, you see area, you see rectangle. So it should clue you into what formula to use. And in this case, we're going to use perimeter equals 2L plus 2W, and area is length times width. Formulas are only good if you know what each variable represents in words. So hopefully you are familiar with these. We don't want to have two variables that we're looking at. We're given another clue. Perimeter equals 80 feet. So what we're going to do is use that fact to solve for one in terms of the other. So 80 equals 2L plus 2W. And what we're going to do, we don't want to have two equations and two variables, so let's solve for L in terms of W. To do that, we're going to go ahead and subtract 2W from each side. That'll leave us with 80 minus 2W equals 2L, and then to get L by itself, we'll divide by 2. That gives us 40 minus W equals L. L represents the length. So now we have that the length is 40 minus W. 40 minus the width, and the width is W. So we can plug that back into the formula for area. Area is length times width. We have 40 minus W, and W, we're going to plug that into the area formula. Now we have one equation and one variable. And we're wanting the maximum area we can find. If you notice, if you multiply the W through there, you're going to get a quadratic, which gives you a parabola. So when we go to do this, we're going to go ahead and put that in our graphing calculator. Caution on the graphing calculator. Make sure you know what your y represents and what your x represents. In this case, our y is going to represent our area, and the x is going to represent the width. So make sure you keep that in mind when you're doing your graphing. So let's go ahead and graph that sucker. When we graph him, here you got the parabola. And there's a lot of things that you can tell by the parabola. You can tell maximum height, you can tell when the height is 0, and the maximum height is obvious. It's the top of the hill. So there's your maximum. Using your graphing calculator, you can use the trace function or the calculate menu to calculate the maximum, and you'll find that that occurs at 2400. Remember, the x is the width. The y is the area. That's the maximum area. Our maximum area is going to be 400. So the width of our rectangle is going to be 20, and our length would be 40 minus 20, or 20. So the dimensions of the rectangle with the maximum area would be a 20 by 20 rectangle, which is also a square. Squares are rectangles. So the next application is vertical free fall motion and the height of an object at time t. So these two formulas you'll see over and over, especially if you take physics. If you know what the variables mean in each of these formulas, it's very simple. And you're given most of the things to fill in the formula. The first one, S of t equals negative 1/2 gt squared plus v sub 0 t plus s sub 0. That gives you the height of an object at time t. You have to know what the other stuff is, the other numbers. You're going to put a number in for g, you're going to put a number in for v sub 0, and a number in for s sub 0. That'll give you a quadratic, which is going to be an upside down parabola when you graph it. S of t stands for the height at time t. The g is the gravity constant. The gravity constant for Earth is 32 feet per second per second. The gravity on Earth in meters per second is 9.8. So it depends on whether they measure your stuff in feet or meters as to which gravity constant you use. So that's the clue on that one. T stands for time. v sub 0, and whenever you see something with a 0 subscript like that, that is initial or starting. So this is the initial velocity, which they'll give you in the word problem, and s sub 0 they'll give you as well. They'll give you a number from that. If it's from the ground, the initial height would be 0. If it's from 30 feet, it's 30 feet. If you're throwing something off a building, baseball off a building or a water balloon off a building, then they're going to give you that. Now, the other new thing is the vertical velocity, and that's v of t. That stands for vertical velocity, and that's basically how hard something is going to hit the ground. In order to solve this one, you have the gravity constant with its g, but you have to know the time that you're looking at, the vertical velocity at a given time. If it is when the object hits the ground, it'll tell you how hard that object is going to hit the ground. So you'll have to figure out what the t is that they need. All right, so let's do our first example here. Oh, well, before we get to that, here's the following equations when we put in what we know, and these might look familiar to you. So s of t equals negative 16t squared plus v sub 0 times t plus s sub 0. This gives you the height at time t in feet. If you wanted it in meters, it's going to be negative 4.9 t squared plus v sub 0 times t plus s sub 0. That's the height at time t in meters. Vertical velocity is the next one. At time in feet per second would be negative 32t plus v sub 0. And lastly, in time at time t in meters per second is going to be negative 9.8 t plus v sub 0. So I just went ahead and put the gravity constant in there so that you could see the differences. Now you'll notice v sub 0 and s sub 0, those are the two numbers you'll have to figure out from the word problem. So let's look what we've got here. You'll fill in from the problem, which is what I just said. Balito's Little League team uses a baseball throwing machine to help train 10-year-old players to catch high pop-ups. It throws the baseball straight up with initial velocity of, and that was a key variable, 48 feet per second from a height of 3.5 feet. There's your initial height. So when you go to find the equation, you've got the two things that you need to get an equation that models it. So s of t is going to equal negative 16t squared plus v sub 0 times t plus s sub 0. I already color-coded them for you, so you know that the v sub 0, that is your velocity. Velocity is in feet per unit of time, meters per unit of time, something per meters of time, like miles per hour. S sub 0 is going to be 3.5. So you just plug those right in and you've got your equation, you've got your formula. That's your quadratic model for this situation. The maximum height of the baseball, you're going to go ahead and graph it and find the vertex. The y-coordinate of the vertex always gives you the height, and it gives you the max or the min for a parabola. So when we graph it, what you end up with, so 48 went in for v sub 0, 3.5 went in for s sub 0. When we go to find the maximum height and how many seconds it will take to reach that height, there's our parabola, there's your maximum height, and there's when it's going to hit the ground. I like parabolas for that because you know when it's going to hit the ground. We're going to need that for the next part of the problem. Maximum height, when you figure that out, it happens at 1.5 and 39.5. So the decimal didn't show up here, but it should be 1.5, 39.5. It's going to hit the ground. That's when y equals 0. When the height is 0 is when it's on the ground. It's going to be approximately 3.07 seconds. So maximum height is 39.5. It reaches that height at approximately 1.5 seconds. I don't know why the decimals didn't come up, but that should be 1.5 seconds. Part C, determine its vertical velocity when it hits the ground. That's when you need that 3.07 seconds. That's when it hit the ground. And we're going to plug that in for t. So here was our v of t, negative 32 because we're in feet, times t plus 48 because that was our initial velocity. So we'll go ahead and put in 3.07 for the t. When you calculate that out, you get 50.24 feet per second, which is pretty hard. Okay, that concludes the 2-3 notes, and you'll have the application activity to do in class tomorrow. Thank you. Bye-bye.